All right, this is chapter 17. It's talking about mirrors. This stuff is not something you can fake. So I know that some of you don't really listen to me while I'm lecturing, whatever, that's your choice. And you just go to the book and you're like, okay, plug these numbers into the equation and then you get the answer. With the ray diagrams that we're going to be learning here, you can't do that. If you do not struggle, if you do not practice, you will not pass the test. It's out of 100 points. It is not curved. A lot of people get 100, so there's no reason to curve it. I have had people get a total of 6 points on it before because they did not practice. They did not struggle. They gave up, and they couldn't do any of the work because they were not paying attention during lecture. So when I'm up here, I'm going to do a billion, well, not a billion. I'm going to do at least 10 ray diagrams up here over the next week. And if you are still struggling, you need to ask for help. You need to practice this. You cannot do it just by watching. You have got to do it. You've got to use a ruler. You can't just sketch these things. So that's why it's going to be very, very important. We're going to start drawing the ray diagrams on Thursday. Yes?
Is this something that we need graph paper for?
You don't need graph paper. I do it all on newspaper paper, but you will need a ruler. So that will all start Thursday. Today we're just going to kind of introduce some of the terms for ray diagrams. So we'll just talk about plane mirrors today and some of the terms. It'll be a fairly short day. And we're going to talk about vocabulary and symbol for these ray diagrams. We're going to calculate the angle of reflection, which is super duper easy. And we're going to talk about the image of a plane mirror. When we're drawing ray diagrams, we won't be drawing them for plane mirrors, because that's really easy. We'll be drawing them for curved mirrors. And again, if you do not practice them, you will not pass. You can't fake this stuff. You've got to practice. And it's not just for this chapter. The ray diagrams that you learn in this chapter are going to go to chapter 18 when we do them with lenses. We just tweak it a little bit. So don't think that, oh, it's fine, it's just one test, I'll fail it, whatever, I'll move on. Well, it's going to haunt you again in chapter 18. So you really got to practice these things. I cannot stress that enough. So I get people that don't know how to do it because they didn't practice it, and it's the day of the test, and they're coming here in the morning asking me how to do it. It's not enough time for me to teach you how to do them. That's why we spend 2 weeks on it. Okay, so practice. It's important. Not something you can fake. All right, let's start with the easiest stuff, the law of reflection. Law of reflection works for more than just light and mirrors. It's a law. It's the law of reflection. You can use this when you're playing pool against your friends to win. And you hit the pool ball, and it's going to reflect at the same angle that it hit as compared to the normal. And that is the law of reflection. So looking at this picture, we have a mirror. We have a light ray, which they call the incident ray. Incident means initial. So it's just where it's light coming in the first place. And then you can see our reflected ray over here. So where's the light going to? Now we have the normal, which is 90 degrees to the surface. We used this normal back when we did forces. And I told you give the surface a thumbs up. So put your thumb up like this on the surface. It's going to stick out 90 degrees to the surface. So if it's the table, it's going to stick up. If it's the wall, it's going to stick out 90 degrees. So this 90 degrees to the mirror's surface, if we measure that incident angle from the normal, it should be the same angle as the reflected ray, but on the other side of the normal. You guys finished with your? Okay. All right. This leads us to our different types of surfaces. Maybe your surface isn't smooth. If it is smooth, then all of the angles are going to be reflected at the same, all the light waves are going to be reflected at the same angle. So they're all going to line up. So you're going to see a nice pretty image. But off of diffuse surfaces, it's very bumpy down there at the microscopic level. So the normals are all going to be a little bit different. Like this one's going to be pointing this way, this one's pointing this way, this one's more here, this one's here, this one's like way over here. So all of the light rays that come in, and they hit the surface, but now they're reflected at different angles. because the surface is tilted differently. And so on this one, you're not going to get a nice image. You're just going to get some light reflected. That would be like trying to look at your reflection in the desk. Is that you see the desk, you see light bouncing off the desk, but you don't see an image. And that's because at the microscopic level, it's bumpy like this. And it reflects those light rays all around. Whereas if you look at a mirror, it's a nice polished surface. So it's nice and flat. It's going to reflect all the light rays in a nice even order, so you're actually going to be able to see an image. Good. So these two types of reflections are called diffuse and specular. For the bumpy surface, it's a diffuse reflection. We can see it. We can see light bouncing off of it, but we don't see an image. And then for a nice flat surface, something that's very polished, we can see an image. So that one is going to be specular reflection. None. You get your foldable. You guys good? Is Brooke good?
Are we allowed to add to the foldable?
I mean, if you want, you won't need anything else. I don't think you'll need anything else. You might think you do. All right. Here's some vocabulary for the ray diagram. The first one is a plane mirror. That's the flat, smooth mirror that I'm hoping that you're looking into every morning before you come to school. I'm sure some of you are. Maybe you should start it. Don't think we can't tell. The object is the physical object that is illuminated or luminous. Yes, that is exactly what it's supposed to say. I know it sounds weird, but we're defining what the word object means for our mirrors. So it's an actual thing. That's what we're trying to say. Or I'm trying to say, I guess. So the object is whatever's being reflected in the mirror. What do you want to see? In the morning, you want to see yourself. Well, maybe you don't want to see yourself, but you should. And the image is what you're seeing as produced by the mirror. And usually it's pretty scary, at least in the beginning. Tame all that wildness. And this image that you're seeing could be two different types of image. It can be the virtual image, which is what you see in a plane mirror in the morning. And this image is going to be upright. So you look upright, your physical object is upright, and in the mirror you see the same orientation. It's upright. And this image is going to appear within the mirror or within the lens. And that's what we mean virtual. It's not projected. It's not a physical projection of it. It is inside the mirror. You can only look in the mirror to see it. It's in this weird mirror world that you wish you could be in, where everything was left right and right was left. And the mirror world. You want to get in there?
It's like that mirror house at the fair.
I hate. Yeah, something like that. So this is a virtual image. It's one that you can't physically touch. You can touch the mirror, but you can't actually touch the image because the image is inside of it.
Oh.
And a real image is one that's projected. So you can use a mirror to project an image. Just like my projector uses a lens to project an image. And this image is projected onto something physical, so I don't need to touch the lens to touch the image. I can just touch the projector screen here. And I can feel it like it's an image, it's a light that's reflected onto it. So this image is actually inverted. It's upside down, which means up there in the projector, there is a screen that's projected through a lens to make it bigger, and that screen, that light, is actually upside down. And you can't see it with this one, but I used to have a projector, and you could see that it was upside down in there. An example of this with a mirror, if you look at the inside of a spoon, right, and it looks upside down, that is a real and projected image. That image, if you shine a light into the spoon, is going to project the image of the light, and you can put a piece of paper at some point away from it and actually see it reflected upside down.
I've always wondered why you saw yourself upside down.
Because of the way the light is bent. It's all reflection. All right, are we good? We're good? Here we go. So more vocabulary, and this is variables. Now, from optics in college, I learned P and Q. Your book uses DO and DI. They're big about the do or dies. But I like P and Q. That's the way I learned it in college. So if you ever actually take optics in the real world, you'll learn P and Q as well. Again, your book is DO-DI. Now, for me, I wrote all your tests. I wrote your review. And everything that you see me do is always going to be P or Q. But if you don't like to pay attention to me during lecture, or you don't like my voice because it's kind of screechy, whatever, and you want to go with the book, it's DO is P and DI is Q. So P is going to be the distance between your object and the mirror. So you in the morning standing 1 meter away from the mirror. That's going to be your P. And your Q is going to be on the back side of the mirror. It'll be negative for your mirror in the morning. So Q is the distance between your mirror and where your image appears. And if you're standing 1 meter in front of the mirror, it's going to look like your image is 1 meter behind the mirror. So if it's a virtual image, if it's upright, it's going to be inside the mirror, and that'll be a negative number. For something that's projected backwards, it's going to be a positive Q, and it'll be upside down or inverted. So imagine you're looking at a coordinate system where this is positive x and this is negative x, so we kind of switch things a little bit. And your mirror is right here. And this little dotted line, slashy line thing means the back of the mirror. And this is the front of the mirror where there's no slashes. So if you, and here's my little object, it's just like an arrow so we figure out which way is up. If you are standing 1 meter in front of the mirror, your P will be positive 1. And since this is a flat mirror, there's no bending of any of the light waves. It's going to be nice and straight. Your image is going to appear behind the mirror at the same height, and that'll be your Q. And the other thing that can be affected is your height. Now, since height is in the Y direction and your P's and Q's are in the X directions, you don't have to scale them the same. That will be helpful when we do the worksheet later this week. Sometimes you don't really want to scale the Y, the heights, but you do want to scale the P's and Q's, your X's. And it's okay to scale them differently since they're in different dimensions. One's up and down, others left and right. Just putting that out there that you can do that if you need to. So this is going to be the height of your object. And for a plain mirror, for a nice flat mirror, your image will be the same height. So if you're, let's say, 3 meters tall, your image height is going to appear 3 meters tall. For a plain mirror only, we're going to talk about curved mirrors later this week, and the rules don't apply to those. There's a calculation that you can do, and we'll do ray diagrams to solve as well. So for plain mirrors, again, these are strange mirrors. They don't follow the normal ray diagram rules. You're just going to copy down what you see. And all you have to do is draw parallel lines. Since there is no curvature to the mirror, our radius of curvature is actually at infinity, so our mirror is flat, which means that our rays do not get bent in any way. They just go straight across. So I usually draw 3 lines. And I do like top, middle, and bottom straight across. You really only need 1 ray because you're just showing that nothing is bent. And you can think of this as like the light bouncing off the atoms, bounce straight through the mirror and shows an image of every single atom, and it all lines up so you can see yourself. So for plane mirrors, P is equal to negative Q. If you stand 1 meter in front of the mirror, your image looks like it's 1 meter behind the mirror, so negative 1. And your height isn't going to change because the mirror isn't bent, so it's going to look like the same height that you are. So if you're 3 meters tall, it's going to look 3 meters tall in the mirror. And these are all things that we know intuitively. It's not really anything we've really thought about, probably. We're putting down variables and a picture to show what we already know. And this will give us a starting point for the curves of the mirrors. Right, and before I get into, I have 2 clicker questions. We're going to talk about the foldable real quick. And that is this piece of paper, and I'll teach you how to fold it, so don't go folding it yet. Anyone's gone tomorrow, there's extra paper up here, like the one that's gone today, needs it tomorrow. It's up here. I want you to take your foldable paper, this nice, really big piece of paper. It's about the size of 2 pieces of printer paper. I want you to fold it in half, hamburger style. All right, and then I want you to open it up, and I want you to fold the flaps into that crease, like a little monster. No, you have to fold it in half first. So you said open it up and then put the arms in? Yeah, so it'll look like... Wait, I'm going to press it down. TJ and I? Why don't you just pull the hamburger saw? I said, I don't think it's also not.
And what?
I found out funny. And so he was like, yeah, I don't usually use the folded paper. And then I said, I need some help. So he's like, you need help with fold his paper. Huge laugh. I guess it's
I know he was holding.
I don't think they make cards for that. You play cards.
No, I heard it.
Okay, so this foldable that you have is going to go over the next 2 chapters. So the front is the flaps. And when you copy the back, make sure you don't flip it this way, otherwise it'll be upside down. Flip it this way. So the front are the flaps, and on one side you're going to have rules for lenses, and the other side you're going to have rules for mirrors. So you really only need to copy down the rules for mirrors right now. So the rules for mirrors will be on one side. I have it on the right side. You can write that at the top if you want. And I'll put this up on the projector at the end of class today. And if you open the other side, so the rules for mirrors is on the right, keep that flap closed, and I want you to open up the other side. So now you have an open flap and a closed flap. So you have rules for mirrors, and then the open inside flap of the other side. This is what you're going to be copying. So you should, when you're finished, hopefully tomorrow, you might get through all of it, you might not, you'll have this whole thing written. And this side, the rules for lenses, will be blank. This whole piece of paper will be blank. And that one we'll do when we do chapter 18. So you'll be responsible for that. On the right side, our right flap, where it says rules for mirrors, there's some equations, a little chart, a couple of ray diagrams, and some rules for drawing ray diagrams. On the inside, at the very top, is, and I just gave you a handout, it says convex mirrors on it and concave mirrors. At the very top, it gives you a convex spherical mirror. So this diagram that's on this piece of paper goes in the top. And then you have 6 more at the bottom. If you flip it around, you're going to see those 6. That's what's going in the bottom. When you copy these down, you need to use a ruler. The ruler is the best way. I really want you to copy them. And if you don't feel like you can do them yet because you haven't done the ray diagrams, that's okay. You can wait on it a little bit if you want, but I really want you to just kind of get comfortable looking at these. And if you draw them in your foldable, you're going to start to see the lines cross and connect. So when we actually start to draw them and do the rules, you'll be like, oh, that's why that goes there. So it'll just kind of help you. So that's what you're going to be doing tomorrow when I'm gone. Again, use a ruler, and Olivia's going to come up here and move it around for you so that you can see it up there. All right. And I am going to try to get this in the copier today so I can scan it and put it on Edline for you. I will try. I don't know if it'll work because it's kind of big, but I'll do my best. And then you can also copy onto the back of it as well. She can flip it over for you so that you can see it. All right, I have 2 clicker questions for you before I show you the homework, and then I will put up the foldable so you can start copying if you want. Here's the first question. It says a ray of light strikes a plane mirror at an angle of 25 degrees to the normal. What is the angle between the reflected ray and the incident ray? You might want to draw that one out. It's trying to trick you.